My name is David Michel, and I'm a data scientist with Thoughtworks, based out of London. I've been with the company about 18 months. I have a background in robotics and decided I didn't want to end up building weapons for a living, so I became a data scientist. The talk is called Patterns for Success in Data Science Engagement. Just so I can gauge the room, show of hands, how many people here are developers? Okay, so most. BA, QA, PM, data scientist, data engineer. Okay, cool. So I've tried to avoid some of the more technical data science-y stuff in this. What I would like you to get out of it, the developers for the most part, are sort of questions to ask and ways to approach projects like this, because the requirements and processes tend to be a bit different. Of those, show of hands again, of those developers, how many of you have worked on a project involving something algorithmic, data science-y? 1, 2, 3. Okay, so very, very few. And of those four, how many of you had any idea what the data scientists were doing? So half out of 4. So we're looking at 12.5%, which is actually better than I was expecting. One of the things we do really poorly is communicate what we're doing and how those processes and requirements are different from traditional software delivery. And I think going forward, this is going to be more and more of a problem as this type of work becomes more and more commonplace in the software development world. Okay, so by way of overview, as I said, this type of work is becoming more and more common. At Thoughtworks, we call it intelligent empowerment. I call it something, I suppose that works. What I'm going to be talking about are patterns and lessons learned from 4 shorter-term engagements I've been on in the last 18 months. Some of the commonalities in thought process and approach, themes for success, maybe just themes for execution. Success, I suppose, is a relative term, and we've seen varying degrees thereof, and some pitfalls to avoid. So again, 4 different clients, 4 short-term projects. I will go over each client and the business proposition in more detail when I come to each one, but by way of general overview, we have 4 clients. One was a web presence for a large South American media conglomerate, and we were looking at targeted advertising, so trying to better identify the demographics of users. The second one is a home recipe delivery service. How many people here are based in the UK, just as a point of reference? Most. Okay, so this is along the lines of Gusto or HelloFresh. You know, you get a box shipped to you with a recipe and all the ingredients required to make it. They effectively had no forecasting and were interested in having some. The third one is a major UK auto reseller. Again, I'll detail the business proposition a bit further when we get to that. And the fourth one was a major UK retailer, which was interested in evaluating a tool they had developed internally to specify shelf capacity for a preset range of products. So first client, again, we're talking about we're talking about a web branch for a media company. Notice the structure I've done here around problem data, model metrics. It's the way I typically think about these problems when I approach them, and they're irrespective of whether or not you understand the details of implementation. It's a good way to think about these kind of problems and projects when you approach them. So in this case, the problem was very clearly defined. They have a very large user base. They have a very large percentage of the population which uses the website. A very small percentage of that are registered users. The registered users we know interesting things about, like their age, whether or not they're male or female. And this allows us to sell advertising to them at higher value. So what they were interested in doing was using those users that they knew those things about, i.e. the registered users, and their behavior patterns, to see if they could map those onto their unregistered users and target them for demographic-specific advertising. They had lots of data, which was nice. Accessibility was not great. Latency was very high. So that's problematic, particularly when it comes to building models. You have to downsample quite a bit. They had an existing model in place, and it worked to a certain degree, which actually turned out to be a really bad thing. And this is often the case, because what they had done was, instead of starting simple, which is again something I will advocate over and over again, they had taken a really, really complicated model, something called gradient boosting. It's not quite a neural network, but it's approaching that level of sophistication, and thrown everything but the kitchen sink at it, which gives you, it gave them something usable. The problem was they had no documentation regarding how they'd gotten to this point. I remember having a conversation with their data scientist when I first arrived, and asking him what he had tried that hadn't worked. The answer was, well, nothing, everything's in the model, which to me seems almost inconceivable, right? Like inevitably, when you do this kind of work, most of what you do will fail. And it's really important that that's documented, so that when somebody quits in 2 years' time, or when they decide, hey, why haven't we looked at this? Let's look at this again. You have a record of things that were tried and didn't work. So you know, at least to the extent that they were tried, you can't try them again in the same way. And metrics. Metrics are so important, right? They're important because this is what defines the actual value of what you're doing. What am I trying to optimize for? So oftentimes, as a data scientist, you will get asked to come in and improve a specific thing. And it's great to have a specific problem to solve, right? It immediately narrows your focus. And data scientists love like nitty-gritty details and interesting problems. But the problem is that there's a shift in granularity required. What you need to do first is look at the much broader picture and say, is this actually a problem worth solving? Does this thing that we're trying to optimize for actually reflect any kind of business value? So in this case, they were optimizing for accuracy. Sounds pretty good. How accurate am I identifying these demographics? The problem is they're considering them equally. And I can guarantee, what are we actually trying to do? We're trying to derive revenue from advertising. I can guarantee you that male versus female is probably worth a lot less than male 18 to 35 or female 25 to 49, because they're by definition smaller demographics. You can target them with even more specific advertising, and advertisers will be even more interested. So why aren't we weighting these things for their actual value to us? These are the questions you should be thinking about and need to ask, and don't need a rigorous mathematical background to understand or to ask. Right? It's about thought process, really. So a little more here. Very limited time. We were looking at 5 weeks. What we decided to do was to scale the level of inquiry and effort. The first thing I looked at was quality of the training data. It's overlooked sometimes, and it's a really poor decision. It should always be a place to start. The next thing I looked at was the period of time over which they aggregated the information they fed to the model, so what we call features in data science. And there seemed to have been little investigation done there. They were taking behavior over the course of a week, aggregating it and feeding it into the model. Why a week? Because that's how society has structured time, and it seemed appropriate. No further thought than that. And lastly, we were looking at if we could select behavioral patterns only from those registered users whose behavior was more analogous to the unregistered users. Turns out we couldn't, or we could, but when we did, the degree of oversampling was incredibly high. So again, this goes to documenting stuff that doesn't go right. It's important you do. It's something that's really important that you do. So yeah, I have at the bottom there, emphasis placed on logging and reproducibility of results. So I've got results in 6 graphs here. Anyone notice anything funky about this one? All I did was look at their registered users and plot their birth date, the distribution of the birth dates. Just on surface, anyone notice anything odd about this? No? This guy here and this guy here seem oddly out of place. Those correspond to birth years 1980 and 1990. If we go down a level here, this is for the 1980 birth year. This is the distribution of month that the birthdays existed in. is there some reason, would there be some reason in South America why massively more people were born in January than in any other month for both of these? As it turns out, the reason is that when one registered for this website through the app they purchased on the iTunes store, for a period of time, their birth date was defaulted to January 1st, 1980, and then January 1st, 1990. Now, when you're trying to predict people's ages by their behavior, and you have a whole bunch of mislabeled data, it makes that proposition a bit more difficult. Cut that out, turns out your model, even the existing complicated model works a little bit better. So again, these are things to be thinking about initially, and you don't need to have a mathematical background to understand this kind of process. If you put garbage into a model, you're going to get garbage out. It's not magic. Second one, we're looking at the period of time over which we're aggregating features. So the persistence of user data. They were picking 7 days. So if we're looking at anonymous users, we had information on about 45% of them. For the registered users, it was considerably higher. What I ended up saying was, well, why don't we take 20? Because past that point, the information gain is pretty small, and it doesn't computationally cost us that much more to aggregate over 20 days as opposed to 7. Lastly, and again, I've put this in here because this didn't work. And when something doesn't work, don't throw it away. Document it so that people know what came before and what had been tried before. So what I was trying to do was better subselect a sample of registered users, those in the blue, so that they represented the unregistered users, which are those in the orange. And it turns out that the behavior is massively different for most of them. So when I got down here, what I've done here is I've reconstructed the features using something called principal components analysis. It's a way of reducing dimensionality in a high dimensional space so you can extract the largest portion of the variance with a minimum amount of information. Often gets used in, or used to get used in image compression, actually. It turns out that in order to get to this point here, the level of oversampling on the small number of registered users I had whose behavior was similar was just insane. So again, didn't work. Spent most of my time on this as opposed to these two, got 2 quick wins, and spent, I would say, 60% of my time working on this, and it didn't turn into anything. But they know it didn't turn into anything, and they won't try it again, or at least they won't try it again in the manner in which I tried it. So next client, home recipe box delivery service. This is fairly obvious. You see a recipe online. You order your number of meals, your size of meals. It comes in a box, and you cook it and eat it. This was very nice. Again, same structure here, right? I'm looking at problem, data, model, metrics, always. Problem was clearly defined. They wanted better forecasting. They were using a set of heuristics they developed. They had clearly accessible data, which was fantastic. The size of the data was less so, because this was a project we'd helped them build from scratch. We had 33 months of history, I want to say, which comprised 6,000 orders from 5,000 unique customers. So any kind of user behavioral modeling is out here because most of your users are one-off. No model, as I said, they're using a set of heuristics, which were getting worse and worse because what they had done initially was offered the same 16 recipes with 8 recipes 1 week, the next 8 the next week, on, off, on, off, on, off. So that scenario made it really easy for them to forecast demand because it turns out, by and large, the people using the service kind of like the same things. So there's very little variance. What they had done for the previous 7 weeks when I arrived was quadruple the size of their menu and just start picking recipes at random and adding them together. With some restrictions. They always had 2 vegetarian options, 2 chicken, et cetera, et cetera. But it still made it, they found it made it extremely difficult to forecast what was happening, and their results were getting worse and worse. So again, they had metrics in place, but they're only considered with the accuracy of the orders. Now, what's the problem here? The problem here is that if I lose, or if I order too much of one thing and it goes off, that might not incur the same cost as another. Beef tends to be more expensive than vegetables. Should I not weight these recipes by what they're actually costing me? right? Because I could develop something that's incredibly accurate that fails on the most expensive recipe and ends up costing me quite a bit more than something which would generally be less accurate. So this was super limited, right? 3 weeks. Give us something to forecast. We were leaving in 3 weeks. So whatever we can do in that period of time, that's what you're stuck with. So what we did was we placed the emphasis entirely on creating this forecasting tool and on budgeting enough time for handover at the end, because we weren't going to be around to maintain this. So it's really important that internally this was understood to the degree they were capable of understanding it, such that they didn't break it immediately and then have nothing left over. So to that end, we ended up using a collaboratory notebook, which is kind of like it's like a Google Docs version of a Jupyter notebook. Not super ideal, but for the size and scale of the project, it fit our needs nicely. And some more results, just because data scientists love graphs. I can never put enough graphs in my presentations. You can see what I've done here is I plotted their 9 weeks of forecasting versus what our model would have produced at the same time. When you build these models, it's really important that you fix them at points in time such that they're not incorporating future information. The way this worked is it would use a rolling window from any point in time, and it would omit from the training data would omit the most recent week and use that as validation. So the results you see on there are the results you would have had at that point in time because it was not incorporating any future information. As you can see, we got a better mean, better median, higher min, lower max, and just in general, improved results. So they were quite happy with that. To my knowledge, they're still using it, which is rewarding. This one kind of spoiled me. This was my first Thoughtworks project, and it was a complete and unmitigated success, which almost never happens on these kind of projects. Third client. So this is what we say B2B, business-to-business auto reseller. They have a certain set of circumstances under which they lease cars to a large number of clients. They largely make their money by reselling these cars to used car dealerships when the leases expire. They have a few things. They have a few ways in which they sell these cars. They have a web portal through which they sell 80% of their cars. They also sell an additional 20% of their cars at auction. And they have the option to refurbish these cars before they resell them. Typically what they do is if the car comes in and it's in perfect condition, they sell it on the website. If the car comes in and it's in less than perfect condition, they auction it. Sometimes the car will come in less than perfect condition and they will fix everything and put it on the website. They had, so they didn't really have a problem defined. They had no sort of experience in these kind of projects. And they were interested in some whiz-bang data stuff to make more money with no further guidance than that, which was nice because I got to define the problem. So it's not that doesn't necessarily make things problematic. The data was a bit of an issue, and this is something you often see is that it comes from disparate sources, which makes it very hard to stitch things together. So, for example, they had really detailed vehicle information, which they kept locally in their data warehouse. But all the sales and refurbishment information they'd outsourced all the auction and refurbishment information they'd outsourced to the partners through which they handled that. And all they were able to do was get Excel spreadsheets documenting these things. And they were identifying cars by plates, not by vehicle identification number, which meant that when I went to do this analysis, there were 50,000 car plates I couldn't line up, which is 50,000 vehicles I can't use in my model. It's not uncommon, but can be highly problematic. And again, no existing model in place, which is fine. No metrics for success, which is even better. I get to define the metric. I'm perfectly happy. There for 2 weeks, wanted to do a proof of concept for some kind of data wizardry. How can we make you more money? I get lots of room to choose the right or the wrong problem. What I ended up doing was a POC for sale, proof of concept for sales price forecasting. So given a car in a certain condition, do I sell this on the website? Do I sell it through the auction portal? Where am I going to make more money? As it turns out, you always make more money when you sell it on the web portal, even when you account for the condition of the car. But they were unwilling to not auction cars. So one of the things you can take out of this then is, or this product would lead to is, instead of fixing everything on the car, Are there certain things I can fix on the car that are going to cost me a low amount of money, but give me a much higher return on the price of the car when I go to resell it, either at auction or through the website? And are those things different? Maybe the people who are buying the cars at auction value certain things more, or just find those attributes more obvious when you see the car in person as opposed to when you're looking at pictures on the website and buying it. So so I built them the same style forecasting as I did for the recipe box, and just looking at by channel condition, rolling forward, can we forecast the price of the sales price of the vehicle by channel and condition? Turns out we did reasonably well. If you look at the sort of median price of a vehicle somewhere in the 14,000, 15,000 pound range, and we're typically between 300 and 400 pounds a month. You can see over here that the prediction for the refurbishment almost exactly mirrors the website, and that's because almost all of the refurbished cars ended up on the website. So we are kind of data poor here in the sense that they haven't tried a lot of different things. There's not enough, and so there's not enough. There's not as much variance in the data as I would like. Last one was a major grocer in the UK. They had a reasonably well-defined problem. They had a tool which they used in a chain of optimizations, which were all isolated. So the previous optimization would say, I need this set of products on my shelves. It was this optimization's job to say, okay, how much of each thing do I need on the shelf, regardless of space? That's a downstream optimization. But regardless of available space, how much of this thing do I need on the shelf such that I'll never run out, or such that I'll never run out of it before it's restocked? So they had accessible data. They had lots and lots and lots and lots of data, which is problematic because it was not at all discoverable, and there were often multiple instances of I wouldn't say the same data set, but what was purported to be the same data set with different values, which makes it very, very difficult to identify what is true and what is not, particularly when the knowledge is all siloed. So I say no existing model in place. They had a tool in place, which was basically a series of SQL queries run on their data warehouse. Not ideal, but they'd sort of evolved to this situation, and it was what it was. And most importantly, they didn't know how well this thing was working. They did it because they'd always done it. They wanted to improve this thing. They had no way to know what an improved version of this thing would look like. There's no metric for something which is supposed to be an optimization. Right? I don't know how. I don't know how on earth you could actually make that situation work. So I had a bit more time here, 8 weeks. Obviously, with no metric for this product, what I tasked myself with was developing a metric for this product. So what makes a good shelf capacity? We want the product to be available, so we want to minimize lost sales. Internally, they were quite interested in labor costs. So as it turns out, you can save a fair bit of money by timing and sizing your deliveries and your shelf capacity, such that if a thing shows up and you can just take it off the truck and put it on the shelf, as opposed to putting it in a storeroom in the back, it ends up working quite well for you. Internally, they'd come up with a figure of like 27p every time they did this. I don't know how valid it is, but it's fine. It's fine as a starting point. And the other thing you'd be interested in doing is minimizing waste, right? I don't want with fresh produce. I don't want too much of it on the shelves because it's going to go bad. I'm not going to sell it. I'm going to lose money. They had some versions of these available internally. Some were good. Some were less good. Availability, for example, they had two measures of. One of which was simply, is this product on the shelf at 9 o'clock in the evening? Which is not particularly helpful if you're restocking it 3 or 4 times a day. I could have just showed up at 9 o'clock in the evening and put it on the shelf, and I missed 200 sales over the course of the day. So this conceptually is what I came up with. I'm going to build you a metric for your shelf capacity generation, and this is going to require, by necessity, this requires a fair bit of predictive logic forecasting, right? I want to try and predict for a given shelf capacity with known information about stores, products, and previous shelf capacities, along with my history of missed sales, my history of that labor efficiency metric, and my history of waste, can I predict all these things for whatever shelf capacity my tool is telling me to use, generate forecasts for costs, add them all together, and then, hey, I know, at least in relative terms, which is better than the other if I'm doing my forecasting well. Again, problem here was too much data and not accessible enough. So what I ended up doing, I had to massively downsample. It took 2 years. I took 2 specific stores with 500 what they call essential products, basically the things that they most want on the shelves. And I tried to see if I could forecast both their labor metric and their lost sales. As it turns out, one worked reasonably well, the other did not. So this is a specific store. I believe this one's in Manchester, actually. And what I'm trying to do here is forecast lost sales at that store over the course of 2 years for those specific products. Now this looks awesome. I have like, what, I've got a mean of 0.31 units. My like 75th percentile is 0.15 of a unit. This is, you show this to someone, they're going to be jumping with joy. Turns out that most of the stuff is available most of the time. So I'm predicting zeros, which is not worthless, but it's not an accurate view of how well I'm doing, right? I have, if you look here, I've got what 42,493 instances. If I look at the lost sales that were not zero, so basically trying to forecast stuff that we actually missed sales on, as opposed to the stuff that was just on the shelf all the time when everybody needed it, that accounts for about 5% of this information. And we still do okay. These are not unreasonable results, but the truth probably lies somewhere in between these two. This was my attempt to forecast the labor metric, which was not good. I will spare you the gory details. Suffice it to say, it turned out that irrespective of what you set the shelf capacity at, the largest impact on whether or not you could just put something on the shelf was how much of it you were shipping and when you were shipping it, which we don't have any control over. Lessons learned, important questions to ask. When you sit down on one of these projects, what do you want to be thinking about? From a technology point of view, do they have historical data, and how consistent is it? This is really important. I love to forecast things. I can't forecast things if I don't know what's come in the past. That's really a non-starter if you're not collecting information. So please, 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 those of you that are designing systems, store the metadata. Don't throw anything out. I want it all. We can decide afterwards whether or not it's useful. Multiple sources. Do I have to stitch stuff together? Where is it coming from? What is the latency like? This massively complicates my universe. So this sort of goes to access and volume and speed. Discoverable. How easy is it for me to sift through your data warehouse? Do you have one person who's been there for 20 years, who knows where everything is, and doesn't bother organizing it in a manner such that someone can sit down and figure out where everything is because he just knows it? So people come to him and he just knows it. Well, great. What happens when he gets hit by a bus? Enthusiasm is also a big one, right? Sometimes you have a hard time selling people on these kinds of projects, and it's important to bring them along at the speed they're comfortable with. So oftentimes, and I'll get into this next, right? We have it's a bit further down, but starting simple is really big. So more important questions to ask: measurement of outcomes. Is there a metric in place? If there is a metric in place, does it mean what they think it means? These are questions that any of you can ask. You don't need a math background, right? Take the 30,000 foot view. What is it we're actually trying to do here? And does the thing they want to improve reflect what they're actually trying to do? Because you would be stunned at how often that is actually not the case. History, reproducibility. What have they tried before? Have they logged it? This is how we do science. This is fundamentally a science-based approach. Log your results, especially the ones that don't work, so I don't waste time trying it again. So some takeaways: start simple. Don't use a really complicated model. They're hard to build on, tough to explain, and they might give you good results initially, but it's not a great starting place. You may end up at a point where you have to use something that complicated, but oftentimes, particularly in clients who've done none of this work before, you can use really simple linear models and get really good results. They're also easy to maintain. Align goals and expectations. So what I found personally, right, is that a lot of the developers I've worked with haven't had experience working on these kind of projects. And it's kind of new and scary, and the time cycles are different. The fact that I can spend 2-3 weeks working on something that ends up absolutely nowhere is difficult to communicate. And it's worth taking the time to have those conversations, right? If you're working on a project with a bunch of data scientists and they're sitting off in a corner and will come and talk to you every month when they want something deployed, I would suggest to you that's probably not a great delivery model, right? The lines of communication need to be more open, more frequent, and they should be able to explain to you what they're doing. Even if they're not producing anything at the cadence you want them to be, you're accustomed to producing anything, they should be able to tell you what they're doing and describe why they're doing it. Please don't be afraid to ask those questions. So finally, yeah, just demonstrate value early, right? There are, you may, and this is something that the data scientists suffer from often, right? Is that they see a problem they find really, really interesting and want to solve that one, as opposed to taking something which is a little more mundane, but is much easier and will add value right away. And this should be the manner in which this kind of work is approached. And again, invest time in knowledge transfer and training, right? If you build something for someone and you have to leave them with it, what good is it if they have no understanding how it works and are not going to be able to maintain it? So thank you very much for your time. More than happy to take any questions.